in some of the earlier videos, we talked about y being directly proportional to x. And whenever you have this kind of a relationship, remember this proportional thing is just a way of us communicating how one thing relates to another. So whenever y is directly proportional to x, you can visualize the graph as being like this, a straight line. So as you increase y, this also increase, x will also increase. As you decrease y, x will also decrease. So you get a straight line like this. Y equals kx, and remember, this only tells you how one thing is related to another. You see, if you have this line here, this line here is also y being directly proportional to x. This line here, you see, or you could have this line here. Well, this line here is also y being directly proportional to x, and you need this k here, because this k here determines which line represents your scenario. So this here will have a different value of k to this one here. So basically, when you're told that y is directly proportional to x, there could be many instances like all these straight lines here, and you need this k here to determine which line you're talking about, which line represents your scenario. So now in this video, we're going to talk about y being inversely proportional to x. So it looks something like this. Okay, and whenever you have this kind of a relationship, you can jump to a graph like this. Hang on, don't worry if you don't understand this bit here. So just like k being, well, just like you have many instances here. K represents whichever line you're talking about. Well, here, 1 over x here represents, well, you can have many, you can have many instances here. So this one here, you see, whenever you get given y is inversely proportional to x, you can jump to this inside your mind. So it will be y equals, well, you need a k here, and then it's going to be times 1 over x. Okay, so the k here determines which line represents your situation. So well, this line here will have one value of k. This one here will have another value of k. This line here will have another value of k. Now k, whenever you times a fraction, it gets multiplied to the top. So you can imagine it as being k over x. Okay, so whenever you're told that y is inversely proportional to x here, you can jump to this graph. And don't worry if you don't understand this for the time being. This graph thing here, I will explain that later on. So, for example, let's say one person takes it takes one person 10 hours to dig this trench. Okay, so one person takes 10 hours to dig this. Now, if you double the number of people, if you times this by 2, okay, if you times this by 2, see this number 2 here. Now then you have to times this by 1 over 2. You see, in this scenario here, y is inversely proportional to x. So it's going to be like this. So you see, when you put 2 in here, then you put 2 in here. So here, well, when you have 3 people working on this trench here, so here you times by 3, and then over on this side here you times by 1 over 3. You see this x here, then you put it at the bottom here. So, well, when you come to plot the graph, hang on, let me show you this. Say one person here takes 10 hours to dig this trench. Now, if you have 2 people working on this trench here, so each person will only have half of the work. So, well, when you have 2 people working on it, it will only take you 5 hours. So it will be like this. If you have 3 people working on it, then it would take you a third of the time, of the original time. So hang on, 1, 2, 3 split into 3, so it'd be something like this. Okay, if you have 4 people working on it, then the amount of time, the 10-hour time, it will divide by 4 because you've got 4 people working on it. So it will be somewhere around here. Hang on, I'm going to split this into somewhere around here. 4. If you have 5, it will be a fifth. If you have 6, it will be so. As you increase, it will look something like this. So your graph will look something like this. Okay, so you can imagine this as being well, it's gonna whenever you're told y is inversely proportional to x here, you can jump to this graph here. Now suppose you have let's say suppose you have some super athletes working on this project here, digging this trench. Suppose you have one super athlete digging this trench. Then that super athlete, let's say that super athlete can dig it in 6 hours. You see, a normal person would take 10 hours. Okay, so this is our graph here. Now let's say you have one super athlete digging this trench here. One super athlete only takes 6 hours. So your graph here will look like this. One person would take 6 hours. So I'm going to guess around here. Now, suppose you have another super athlete. Now you've got 2 super athletes working on this trench. So normally it would take 6 hours. You see, a normal person would take 10 hours. A super athlete will only take 6 hours. Now you've got 2 super athletes. So you're going to be able to dig this in 3 hours. So here it will be 3 here. Okay. Now suppose you have 3 super athletes digging this trench. It will only take 2 hours. And so on. And then if you keep on going, you see you have a second line representing another scenario here. You see the black line here represents your normal people digging this trench, and then you've got a purple line here. It represents the super athletes digging this trench. You see, this is why we have so many different lines here to represent different scenarios. So here the black line, well, whenever you're told that y is y is inversely proportional to x here, you can jump to this. Y equals k over x. You see, now for the normal people digging this trench here, you will have one value of k. Okay, now looking at this one here, for the super athletes, you have another value of k representing the super athletes. You see, you need different values of k in here because it represents different scenarios. So when you're told that y is inversely proportional to x, you can only visualize these kind of graphs, but then you have so many lines here. This is why you do need this k here, because it represents different scenarios, even though the relationship is the same. I know it seems a bit weird, but I will give you some more examples. Okay.